Hello everyone. I'm Andy from ThinkMo. I'm currently teaching the CCIE course. As of today, I'm going to share with you some technologies related CCNA, CCNP, CCIE. Topic today is: how can two hosts communicate with each other in IPv6? So I've talked about that in the last couple of videos. It's the word ARP in IPv6. It's essentially NDP, address resolution function, because there is no concept of broadcast in IPv6. So let's get back to the main point. How can two hosts communicate with each other in IPv6? The first aspect is that it relies on IPv6 address resolution. We've already talked about that. It then involves two types of packets in IPv6. Some of you may be confused. We don't talk about NDP. Why is IPv6 involved again? Because in IPv6, implementation of NDP functions, it mainly relies on the ICMP protocol. So in the case of ICMP in IPv4, that's the equivalent in IPv4, such as address resolution. It does not depend on ICMP. And in IPv6, it's mostly based on ICMP, because there is no concept of ARP. So in IPv6, two types of packets are involved: NS packets and NA packets. The NS packets are called neighbor request packets. NA packets are called neighbor notification packets. The third is to request link layer address of the other party. It's what we usually call a MAC address. So let's look at it in detail. Request the link layer address of the peer party. There are steps involved. Let's take a look at this picture. It relates to address resolution function of IPv6 NDP. The two hosts must communicate with each other at this time. That is, PC1 encapsulates the corresponding header, because there is no broadcast concept in IPv6. So the first thing that comes to mind is three-layer header encapsulation in IPv6. First of all, the original address is its own interface. Global unicast IPv6 address is 2001.164. The destination IPv6 address indicates the multicast address of the requested node. Once the peer party is configured with IPv6, after the global unicast address will be added to the multicast group of the requested node. By default, it's handed to this group. The requested node is through. The value is a global unicast IPv6 address. They have a conversion relationship. See the previous video for more details. And in the process, it involves layer 2 header encapsulation. The source address is the link layer address of interface. It is the MAC address of the interface. And the destination address is this multicast MAC. This multicast MAC is multicast address of the requested node. The mapped multicast MAC address, rather than the global unicast IPv6 address of the other party, indicates the corresponding multicast MAC address. So this is a very important aspect. So this IPv6 multicast MAC, it starts with 43, among other things. And then this is the mapping multicast address of the requested node. That's the next 32 bits. Then there are the IPv6 packets. He will send an NS packet whose type is 135. It is called a neighbor notification message for the data part in IPv6. That's the data part. Data field. It contains the source MAC address. That is to say, it carries link layer address of the interface. Then send it to the other person. When sent to the other party, the peer party received the packet. First of all, we see inside this 3-tier package, You can see the multicast address of requested node. It turned out to be mine, because I configured a global unicast IPv6 address. Therefore, the multicast group of requested node is added. At this time, it will respond to NA packets. It is the neighbor notification packet. We can look at the following text field. The packet of this NA. I'm going to wrap it on my side. I got the MAC address, because the other party is in the IPv6 packet. It's already been carried. Then in the NA packet that the other party replies to me. It's 3 layers of encapsulation. First of all, we need to get a general idea. Layer 3 encapsulated source address. That's PC2's 2001-2 global unicast IPv6 address. And the target address belongs to the other party. Global unicast IPv6 address. That's 2001-1. Then there is the layer 2 address encapsulation. Its source address is the link layer address of PC2 interface. That's the MAC address. The destination address is the other party. Link layer address of the interface. So we take this message. You can see it is a unicast packet. Related NA packets. It's in IPv6. Carries its own MAC address. It is the packet that PC2 sends to it. I also carry my MAC address in it. This completes the two-way interaction process of the link layer address. And then we get everything after the link layer address of the peer party. Then the communication can be exchanged. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.